last session up, which is Ross and James. It's a multiplayer game. Before I forget, while they set up, for the first time ever, well, actually second time ever, because I did it this summer too. I got kid sizes HalfStack shirts, medium and large, a few of each. So if you have kids who are like ages maybe 5 to 12, depending on their size, it might fit them. So if you want one for them, just come up now. We're all just getting set up, and I'll give them to you. And if not, that's cool. I'll just give them more to my kids, I guess. Thanks. Any other people with kids who like HalfStack shirts? If not, that's fine. So after their talk, we'll transition to pub quiz after party. Food will start to roll in over here, pizzas, as well as leftover stuff. Drinks, of course, will remain open. I'll get set up with the pub quiz prizes up here. You can start to form teams by making circles with 2 chairs of like 6 people. I'll give out the quiz sheets and pens, and once you have the quiz sheet in hand, you should not use an electronic device until the quiz is up, because there's no cheating. And that's it. Any questions? Okay. It's a bit finicky with like just really
Just going to test the
Let's turn it down.
Yeah, that works.
Good music to get fired up.
Yeah.
Do you need more space?
No. You should be fine.
This is where we try to break them. It's massive.
So yeah, we were literally finishing this earlier on today, so hopefully it will work, but we'll see. But yeah, so welcome. This is a massively multiplayer serverless game, as in you are all going to be participating. It builds very much on a few of the other talks that we've seen. So we've seen some stuff on WebSockets. We are going to be using WebSockets, but we're not using Ably, so apologies for that. We're using a different provider of the Amazon variety. We're James and Ross. We are originally Orange Jellyfish. I'm the CEO of Orange Jellyfish, a JavaScript and serverless consultancy. We are obviously always hiring, so if anyone wants a job, just come and find me afterwards. And James, we're originally Orange Jellyfish. James is technically still Orange Jellyfish, but he's also the CTO of a health tech startup called MindStep, which is incredible. It's doing a lot of work on brain health and stuff like that. If you want a demo of that as well, find James or find me. It's really exciting. I mentioned that because it was a project that Orange Jellyfish originally worked on. One of the things that we do, we work with really early stage startups. We help them to get off the ground in the right way. It is was our first success story and continues to be a success story. So it's a really interesting project. So today we're going to be doing a massively multiplayer game. The massively multiplayer game we're doing is not particularly complicated. As you can see, it is the game of Pong. So Pong, originally 1972, it came out in the format of an arcade machine. It was a actually something that we built 5 years ago as a multiplayer game for an internal conference that we did for Tesco. So James and I used to both work for Tesco. And back then, WebSockets were the same as they were now, you know, a standard web technology. But we built it using a straight Node.js server. We used a Redis cluster as well for doing some state stuff. But Orange Jellyfish, we're a serverless consultancy. So we thought, do you know what? We can do this, but we can do it in a serverless way. So we've had a go. There are some quirks. We've never really seen it scale to the number of people here, not real people. We've dropped a meme in just because we saw the talk earlier about the memes and design systems. I loved it so much. It was great. There are a few caveats. The code is rough and ready. It's nowhere near reflective of the sort of code that we produce. If we're producing it for clients, so nobody take that as this is the standard that we produce. The concepts and some of the challenges about the things that we've solved are more interesting. Obviously, with the last talk of the day, we're not going to bore you with technical stuff. If you want to, we're like a nice wrap up towards the end of the day. We don't mind if you leave and go and get a beer now and come back. That's absolutely fine. We are going to do some technical stuff. The other thing is, this is not bleeding edge. We're not doing anything brand new. We're doing stuff that has been done before, but we're just putting a slightly different spin on it. So, yeah, now they're out of the way, we can kind of talk about a few more other things. So, serverless, a massively quick rattle through it. How many of you are familiar with serverless as a paradigm? Cool, most of the room, perfect. So, serverless is hugely exploding, it's taking off. It is not the idea that there is no server, although, if you go in to speak to some of our customers, they believe that they're going to save money straight away by getting rid of all of their servers and they don't have to pay for anything anymore. That is not the case. It is basically someone else is taking care of running the server for you. In our case, it's going to be AWS. You get all the benefits of on-demand pricing, scaling, blah, blah, blah. Right? I'm not going to talk to you about technical details. Today, we're going to be using Lambda, but we could use Fargate. We're going to be using API Gateway, EventBridge, AppSync, DynamoDB, loads of logos. I mean, there's so many AWS logos, I don't even know what these AWS logos are anymore. Especially those ones at the end. I think that might be some sort of security thing. Okay, IAM roles and CloudFormation. And we're doing it on the serverless framework. Code is all available. We'll share it with you afterwards. But I think rather than me talk, I think probably we should just get on and play a game and see how it runs. So, it's very, very simple. It is no coding. There is no downloading anything. There's no installing anything. If you can scan the code, hopefully the code works. We generated that built-in tool in Chrome if you've never seen that, hence the dyno. Go to pong.oj.fish. It should be secure. We do everything HTTPS by default. And you should automatically be allocated a color. You should get either a red or blue, and you should get a paddle. And what we're going to do is we're going to bring the Pong onto the screen. There it is. Okay. Wow. So we've got 42 players already on, and it's growing and running quite slowly. If Red missed this, oh, well done. You got your sound on. Have you interacted with the DOM? So what's going on here is, I'm sure you're all playing, you're pressing up and down going, it's not going in the direction I'm pressing. What's going on behind the scenes is, it is averaging all of your decisions and it is making a collective decision. So if you have a blue, you are the blue paddle. If you have a red, you are the red paddle. The sound effects you hear are original.
Gary, what color are you? I'm blue.
The red team wins.
Okay, so what's happened is, I don't know, why has Clippy got on here as well? Gets bloody everywhere, doesn't he? Okay, so what's happened is the game has ended. The Lambda has timed out. If anybody reconnects as a player, we spin up a new game and you can carry on. The number you see in the top left is a relative indication of the delay in the game receiving messages from the server. It is all over the place. Network latency in this place is horrendous. This version is especially slow. We're going to talk about why. We'll let you finish this point off, because obviously everyone's so engrossed in this. You're not actually listening to what I'm saying. I bet if I said there's free beer at the bar, no, nobody's moving. Okay, right, I'm going to hand over to James. We're going to look at why it's so slow. We'll hopefully speed it up a little bit, although if you've been on the Wi-Fi here, you'll probably understand why it's a little slow. And we'll jump from there. We'll let you finish this point. It's going to be...
We've muted that tab so we can... Can't change what I'm looking at.
Good save, Blue. The funniest thing is watching James here trying to get the slides back up. Right, the game will keep playing. We'll come back to the game, don't worry. We'll speed it up, we'll make it even more competitive. Right, handing over to James.
Right, so obviously, as we've seen, we have the same challenge as everyone else here now. There we go. So the problem, there are a few problems with the setup we've got, the way this is running, but the number one problem by far is latency, kind of across the stack with everything that this is doing. Network, literally from your devices, trying to send messages, the Lambdas, when they start up, I'm sure you've all heard about Lambdas and their cold start time. That's probably less of a problem here because the Lambda, especially the game Lambda, should be warmed up. It should start quickly. The Lambdas that process incoming messages are very quick anyway. We're using DynamoDB to store inputs from players. Reading and writing is additional latency, although it was actually surprisingly fast. Some of the writes in particular, so deleting inputs from users on each kind of tick of the game, surprised us at how fast it was. Can you remember the numbers? It's sub 10 milliseconds to delete hundreds of rows. And then, which was actually the biggest one, sending WebSocket messages back to the clients via API gateway. Takes up the vast majority of time on each tick of the game loop. So to discover where those problems were, what the causes were, we had to do some profiling. CloudWatch is an AWS service that effectively does monitoring. It aggregates metrics, it allows you to graph them, and so on, alert on them. You can actually fire your own custom metrics into CloudFormation. through code, through something called the CloudWatch Embedded Metrics format. So we started publishing a number of custom timing metrics throughout kind of the loop that the game runs. After, for example, things that could potentially be slow, writes to the database, firing messages back to clients, and so on. We'll show you that very shortly. You can do it through the CloudWatch API directly, but there's a module for Node.js, the AWS Embedded Metrics Node module, that makes it really easy. A couple of lines of code and you can fire timing information or anything directly into CloudWatch. It's worth noting that unfortunately it only gives you 1 minute resolution when you do it that way. So when we show you the graphs, we can't show you a nice real-time graph of performance while you're all connected because there's a fairly significant delay. There's some example code. With some metrics configured, we needed to look for a way to put some real stress on the system. You may have heard of a tool called K6, which is a load testing tool. It bills itself as the best developer experience for load testing. It's got really good WebSocket support. You can write tests in JavaScript. You can run them in the cloud on k6.io or on self-hosted runners. That's what we're doing here, and we'll show you a demo in a minute. A K6 instance deployed to our ultra-secure data center, which is actually a Mac Mini running under a desk in our office in Bracknell. So let's have a quick look.
So James is just going to, we're just going to show you this quickly. We know you want to get back to the game and get competitive. We will divide you up into teams and play you properly. But the really interesting thing about the metrics was it showed us the bits that we thought were really slow wouldn't be really slow. The bits that are slow were quite easy to make a bit faster. We can make it a bit faster. We will make it faster. Don't worry, you won't have to play at the speed you're playing. It will get quite hard. But what we're going to do is because the Wi-Fi is a little bit sporadic here, we're just going to log in to, or we're going to try and log into that remote Mac Mini, run the load tests, show you the game running with 500, basically 500 players playing, see what it does. We'll show you the performance metrics.
We might not do any of that.
Right, we might not do any of that because we can't even. The Wi-Fi can't even let us remote. So we'll just ping you up the charts that we made, which are on the tab that you just had up on your screen. Yeah, so this is some of the stuff that we've got going in. If you actually just refresh this, Jane. Oh my God, that's quite slow. You may need to change the resolution to 1 hour if possible. Cool. Okay, so this is literally just showing you the game you just played. We're using some bloody Clippy's back again. We're using stack chart, so you can kind of see some stuff that's going on. The blue represents actually the game logic loop that's going on. So we're within kind of 100 milliseconds, which means we should be able to respond. The interesting bit's the red. The red is basically the time that things are taking to, the API gateway is taking to send back all of the information down the WebSockets to all the clients. The chart on the right just shows you the invocations we had on the Lambda. So when you were playing them, we just hit 2,500 over a 5-minute period. That's pretty light for us. If we could show you the load test, we normally get up to sort of 20,000, no problem. But you can see it's quite slow. The message send is taking a while. And because the message send is taking a while, that actually introduces quite a lot of latency into the system. So what we're going to do is we're going to just try and deploy. We're going to show you some things we did to fix that. We're very keen to get you back to the game, so we will race through this. We will do the deployment. We'll get you back playing again. So we talked about how we built this before 5 years ago. We had a node. We just had a node process running. Anyone who's run node knows you can just run it, no problem. Anyone who's used a Lambda or knows what a Lambda is, it's really designed for short events, process the event, shut down the Lambda. So not really designed for what we're doing at all. Would we build a game on a Lambda again? Probably not. What we've actually ended up doing is basically creating a huge loop within the Lambda. The Lambda can run for up to 15 minutes on the timeout. If you're running Lambdas for 15 minutes at a time, I'd suggest it's probably not the right technology to be using. You should probably look at doing something else or breaking down what you're doing into smaller pieces. But Lambdas can run for 15 minutes. AWS love to take your money. If you keep running lots of Lambdas for 15 minutes, it actually does start to cost you. So what we do is we set a long timeout. We run a Lambda. We run basically a loop through that Lambda, so the game keeps running all the time. We store the game state in the memory of that Lambda, so we don't need to worry about reading or writing from a database every time you go through. So if that Lambda dies, the game's gone. Thankfully, the Lambda never seems to die. So that becomes basically a single point of failure. Everything else you see scales nicely. So incoming messages, as in up and down paddle events, they're scaling across Lambdas. The more paddle events that come in, the more Lambdas that we scale up. The same for anything else that's going on, connect events, disconnect events on the WebSockets. We're not going to talk to you about how WebSockets work. Like, it's too late in the day for that. But it all scales nicely. The only bit that doesn't scale is the Lambda, because it has to maintain the logic. So what we noticed is that obviously, and we've just shown you, is that it's the message sending that actually is the slowest part of the kind of entire process. And that's the bit that gets slower the more people that connect. But actually, we don't need to be sending back anybody else messages. So if we take the fact that we're sending you a message back, everybody right now is receiving all the game state, you don't need it. What we can do is we can massively improve the send message rate, because we only need to send it to clients that care about the game state. And in this case, the only client that cares about the game state is anybody that's displaying the actual game that's going on. Originally, when we tried this, we had everybody connected, able to see the game on their phone as well, but that was just a bit antisocial as well. So we're just going to quickly deploy that. If James can drag the window over. This is another huge benefit of serverless. So quick to deploy stuff. We're just using serverless framework. We're going to deploy one function. James seems to have lost the ability to use his laptop. Would you like me to take over? No. I think it's because you're full screen over there.
I'm not.
So again, we're not going to talk through code. We know it's way too late in the day for that, and we know our code is not particularly great. Do not spot anything and go, what the hell are you doing? Why are you doing that? Effectively, what we're going to do here is basically we're going to filter out outbound connections. So James needs to have commented out this line, which he hasn't done, so it will break for now. But thankfully, you need to comment out this line right here.
Oh, I've unconnected it.
Yeah, you need to comment out the line that says connections, though.
Sorry.
Otherwise you will break the...
Yep.
That's why it says swap. So what we're going to do is we're now only going to send outbound WebSocket messages to the displays. So we're just doing a basic filter on the array of connections.
That's done.
It did say function deployment skipped. Did you save it?
Yeah.
Okay, all right, we'll give it a go. So that's a massive win. This is our game loop. As I say, we're not going to talk through exactly what's going on here. This change should make the game far more playable and hopefully a little bit more competitive. Here's a chart of some load testing that we were doing that was showing. So this is where we were running it earlier. So we got to 14,000 invocations in a 1 minute average, that is. Thankfully, we are on free tier on this account, so it didn't cost us anything. And the message send rate, as you can see, went up. And then this is post the fix that we've just deployed now. So it kept basically the game loop speed within that, well, basically linear, irrespective of the number of connections that we got on. Cool. So we've massively just kind of skipped over all of the technologies we're using, but what we're actually doing is we're doing a lot of DynamoDB reads and writes. DynamoDB is fantastic, and you know I'm happy to have a conversation with anybody about it. I'm not a particular expert, but I really like it. Everything we do, we generally use DynamoDB as our data store. It is obviously serverless and all managed for you. Read and writes are particularly quick in DynamoDB. They're also very linear, so it's quite good. But we did kind of look at some other options. We store game state just in memory, but all the connections are stored in DynamoDB, which means we are doing a read and write every time we do a game tick to send everything. When we originally built this at Tesco, and this is when we were on Node, we were using Elasticache, which is basically AWS's managed Redis service. We deliberately didn't do that because it's not serverless. It's actually, it's actually a managed EC2 instance that's running for you. So that kind of broke the idea of doing it serverless. What was quite interesting, and this is quite new, it's getting a lot of traction, I think, within the serverless world, is there are a lot of third-party serverless cache offerings that are coming out. One that's particularly interesting that might be worth a look at if you do a lot of serverless stuff and you're interested in cache is something called Memento. It's just got a round of funding. I'm completely not involved. We didn't have time to try it, but it gives you a very nice interface onto a very fast cache that is serverless. So that's something that you could have a look at if you're having similar performance problems and don't want to use something like Elasticache, which is as I say, it's a managed continuous cost as opposed to a serverless offering. So we've done the deployment. We're going to try and have another game. If you're all still awake, we'll jump over to it again. Hopefully, it'll be a lot faster. Depending on how the game's going, if you're finding it too hard, we can obviously make changes in real time, paddle sizes, ball speed, all that kind of other stuff. So we'll let you have a game for a bit. Dylan's obviously hounding us to.
No. I thought you were done. That's all good.
Yeah, that was good. The game will reset automatically, so blue team, you may have a chance on the next game. We are dealing with kind of.
The red team wins.
Oh yeah, well, as I say, original sound effects. We'll let you have a quick game.
Did you make those yourself?
I did make those myself.
Brilliant, yeah.
I didn't want to get sued by Atari or anything. Obviously, it's so popular.
I will say this was about as well as the one on the test, though, which is impossible.
Yeah.
Like the steering wheel overshoots every turn.
I do like the collective decision making here. It's kind of shoots well over, goes well down, and then eventually kind of course corrects, and you seem to be doing quite well. What we may do is just we're just going to crank the hardness up a little bit. You're too good at this. Just take the delay out. 50 millisecond delay.
I don't think Red can lose. I'm sure he can stand.
Blue team wins.
Well done, blue team. We'll maybe put it up, let you have another game. Oh, okay. Oh no, now we've got to hardcore mode. Come on, blue, to the top. Nice, sneaky. I think the game is about to come to an end, so we'll let it play out, and then we'll say thank you very much. I think it's quite actually incredible. You are adjusting yourselves to the extreme amount of latency imagined to get it.
The red team wins.
Perfect. Well, thank you very much. I hope you enjoyed it. Yeah, if anyone does have any questions, please don't ask me or James, because we literally don't know. Yeah. The angle of the ball was coming off was supposed to be calculated, but we just replaced it with a math.random at some point. So if that explains why it wasn't working, but we'll get it up later and maybe let you have another game as well.
I think the lesson learned is if you're going to defy the laws of physics and gravity, at least have cool sound effects.